Okay, so we just covered JAXB basics, which is which covers the basic concept of JAXB compiler for generating Java classes from XML schema. As you can see, in JAXB, basics was used to generate Java from XML schema. In JAXB 2.0, we are going to actually see how XML schema could be created from Java classes. Okay, so here, JAXB 2.0, we are going to take a look at the improvements made over JAXB 1.x, and then we're going to take a look at JAXB 2.x architecture, and we are going to again see data type mapping, and then we are going to see some of the annotations that you can use to control the XML schema generation from Java classes. Okay, so let's take a look at the first topic. JAXB 2.0 improvement over JAXB 1.0. So the JAXB 2.0 adds support for binding Java to XML schema. Okay, and with this package to control the binding. So in JAXB 1.x, they support XML schema to Java. That's what we just learned in JAXB basics, right? So we were able to create Java classes from XML schema. But JAXB 1.x didn't support Java to XML schema. Okay, so JAXB 2.0 adds that feature. Now, in JAXB 2.0, you can create XML schema data types from Java. Okay, so now it's bidirectional. And it also provides some better implementations on various JAXB packages. So significant reduction in the number of generated schema-derived classes and smaller runtime libraries. So some runtime improvement. So if you take a look at JAXB 2.x architecture, the only difference is basically now there is a schema generator added. Okay, so rest of it is exactly the same as JAXB 1.x. So the schema compiler is XJC, which is used to generate Java classes from schema. Now in JAXB 2.x, from Java classes you can generate a schema. Okay, so the schema generator is added item in JAXB 2.x. Alright, so architectural components, again, these are a little bit of repeat. Schema compiler is something that we have seen already, that's XJC. And then binding runtime framework, again, that is pretty much the same pretty much the same as in JAXB 1.x. Again, schema generator, that is the one that is added in JAXB 2.x. So it maps a set of existing program elements, meaning Java code, to XML schema. And this mapping is described by program annotations. So you are going to use the annotations in your Java code for mapping your Java code to XML schema data types. So again, this is something that we have already seen. So a schema has document instances that are compliant with that schema. And from the schema, you could generate Java B classes, JAXB-based Java classes, and object instance of those classes. And then you can do onMarshal, reading XML document instance into objects, and then you're going to marshal and to document instances. So this one didn't change. This is the pretty much the same picture we have seen in JAXB basics. Okay, default data type mapping. So, these are the default data type mapping that we have seen before, right? So these are XML data types and Java data types. And again, these are XML data types and these are Java data types. Okay. Now, these data types are being used in bidirection. Okay, so all right, so JAXB element. What is and why JAXB element? Again, JAXB element class is introduced in JAXB 2.0. When XML element information cannot be inferred by derived Java implementation of an XML content, a JAXB element object is provided. Okay, so the reason is because sometimes JAXB cannot work with POJOs because a schema cannot be mapped exactly onto Java. Okay, so in those cases, JAXB element objects are necessary to provide additional type information. So if somehow the compiler, the JAXB compiler, cannot generate the Java classes for whatever reason, then it will actually generate JAXB element wrapper class, and basically it lets you do whatever you want inside that JAXB element class. Okay, so this object has methods for getting and setting object name and object values. So we'll see some of the usage of JAXB element later on. Okay, so Java to XML schema annotations. Again, these annotations are used for creating XML schema data types from Java classes. So so we are going to actually talk about each of these in a bit more detail. So there are 5 JAXB annotations that you can use to Java class. XML type, XML root element, and XML schema, XML access type, XML access order, XML schema type, XML schema types. So we're going to actually look into each of these, actually the most important, the annotations in the following slide. Okay, so let's take a look at how you can use XML root element. So when top level class or enum type, typically we are talking about top level class, like a purchase order type class, is annotated with XML root element annotation. That means the value is represented as XML global element in an XML document. Okay, and so this could be used with other annotations. So we're going to actually learn about these things later on. Okay, so let's see an example of XML root element. So suppose if you use XML root element with a class point, okay, then it will generate XML schema like this. So it will generate complex type of point, okay. As a default, it will take the name of the class and use it as the name of the type, okay, and element as well. So it does contain 2 properties, X and Y. So those 2 properties will be set as a sequence of 2 elements, okay. And then you create the global element using this complex type. Okay, and as a convention, it's going to use the same name for the element and the name of the type. Okay, so basically, XML root element is creating a root element in your XML schema, in this case, point. Okay. Okay, so let's do exercise 1 and exercise 2. So exercise 1, we are going to use XML root element annotation, and then we are going to generate XML schema from US address class. So let me actually explain exercise 1 and 2 one more time, looking at the lab documentation. So here, when you run the application, it will display an XML instance, okay, like this. So let me run the application, then I will just continue explaining it. Okay, so let me just close these guys, and let me open the project, and this is JAXB 2.0. JAXB 2.0. And that means okay, so the one that we want to run is the XML root element project. XML root element project. So when you run it, it's going to just display XML document instance that gets created. So this is basically what you're going to see. You can see this is a purchase order XML document instance, which contains a build to and the ship to. Okay. All right. So let's see how XML root element is being used here. Okay. First of all, let's take a look at the so I want to actually see the purchase order type first. So this is where XML root element is used, and the name we are going to use for that element is going to be purchase order. So otherwise it's going to use purchase order type as a name. Okay, and so in this case you can actually give a name, and then you can also give XML type, which is a purchase order type. Okay, so it will actually create an element called the purchase order, but it's going to use a purchase order type as a complex type. Okay, so that's purchase order, and inside is using US address as a build to and ship to. Okay, so if you take a look at the US ship to and build to, again, US address is also is annotated with XML root element. Okay, with this namespace. So this guy is going to have his own root element, the element, global element. Okay, and the type. Okay. So in this case, if you take a look at the main.java file, basically we have US address object, US address object, and then this is already have a package created. So we have new purchase order type, and then we are going to actually marshal it. Okay, we are just kind of read so this is the case. We are creating internally in-memory image, and then we just write it out into using a marshal. Okay, so that's basically what gets displayed. Okay, but we don't know what is the schema that was generated internally, right? So that is actually the next exercise. In exercise 2, we are going to in fact generate the schema as well as part of our exercise. So this is the XML root element to generate schema US address. Okay, so let's run the that guy generated US address. You can actually run this too. Okay, so let's try this guy. If you run it, you can tell now this actually generated XML schema. So these are the XML schema that were generated internally that is used to create the XML document instance that we printed out in exercise 1. So you can see this is the this is schema, and it just import the schema 2, which is this guy. Okay, and so basically this is creating the global element called the US address. And then it also defines the complex type. Okay, so when you actually see in here US address, we use the XML root element. What that means is that I want to create an element called the US address with the U is actually small letter, and also I like to have complex type reflecting the type of it. So that's basically what you're seeing here. Okay. Now, if you run the purchase order, if you want to actually see the schema of the purchase order type, let's actually try that on as well. Now, what you're going to see is, again, we have here we have so you have a US address element here, and then we import. It's gonna import X schema number 2. The schema number 2, you are going to see an element called the purchase order, whose type is a purchase order type. And then we have a purchase order type like this. Okay, so the reason is because in here we named it as a purchase order as an element name, but the type is purchase order type. So if you actually give like a purchase order XYZ, so let's actually change that and run it again. So in this case, let's try to change my packages address. Yeah, so my purchase order. Here, instead of purchase order as an element name, I'm going to actually use a purchase order 1, 2, 3 or something like that. So in this case, it's going to use purchase order 1, 2, 3 as an element name while using purchase order type as the type name. Okay, we might as well just change this one as well. So we'll just change 4, 5, 6, something like that, and save the change, and then we are going to actually run it again. So this time, if you actually see the output, you can see the element name is a purchase order 1, 2, 3, and the type is using is a purchase order type 4, 5, 6. Okay, all right. So we are basically exercising XML root element as well as XML type. Okay, so I'll give you guys about 5 minutes to try this exercise. Yeah, by the way, I didn't actually show you the code for generating XML schema, so that is in fact the exercise 2. So if you take a look at this code, yeah, so Yeah, so I'm actually using what is called the schema up resolver class, okay, and that's the one I'm actually using to display the schema, internally generated schema, okay. But you don't have to actually understand this code. This is just the utility class that I'm using to get an access to internally generated XML schema. That's all, okay. Here, yeah, 2.4, you can actually add a name attribute. Okay, so here name equals my US address, and then you can see it's going to change the US address name element is going to be my US address. Okay, so you can try that one as well. Next is the XML type annotation, which we have already seen the example of it. So it maps the class or enum type to XML schema type. Okay. So a class must have either public zero-argument constructor or static zero-argument factory method in order to be mapped by this annotation. And one of these methods is used to during unmarshalling to create an instance of this class. So basically, you have seen map XML, typically used mapping XML complex type. So XML and the name is mapped to anonymous type. And you can also specify prop order attribute. So let's see example of this. So suppose if you want to have US address and XML type, okay, and you can specify prop order. What it means is in Java class there is no order is enforced, right? So even though the name and street and city and state and big decimal get zip, these properties, there are no concept of ordering of the properties in Java, but in XML it does, right? So if you want to make sure that XML schema that gets generated for US address is in fact in this order, then you can specify property order. So in this case, I want to have street first and city first, state next, and zip it next, and the name is the last. In that case, XML schema that gets generated, complex type that gets generated, is going to be in sequence of, you can see street, city, state, zip, and name. Okay, so basically XML type is used to create a complex type for that class, and then you can specify the order of that properties reflected in XML schema. This is another example. So if prop order is null, that means you don't care about the order, and then what gets generated is going to be all. Instead of the sequence, it's going to be using all. So in this case, it doesn't actually impose ordering of these elements in XML. Okay. And this is the case, map a class to global element with the anonymous type. So in this case, if you don't give a name, so in this case name equals null, then it's going to just create global element with anonymous complex type. Okay, so instead of explicit complex type with a name, it will just use anonymous type internally embedded into the global element. This is the example 4. So map a property to local element with anonymous type. So in this case, we have the XML type name. So in this case, we are actually using it inside the address. Okay. So so this is the case. I should actually emphasize this one. So if you have US address as a property of invoice, and then we have the XML with no name here, then again US address is going to be inside of the US invoice complex type. Okay. Example number 5. So map a property to an attribute with anonymous type. So in this case, we are actually using XML attribute, and here with the XML value. So basically in this case, the price is going to be specified with So this is actually used with the XML type. Okay, by the way, in this case, the price is going to be in an attribute. Okay, rather than an element. Okay, in this case, XML value is big decimal. This is map the class to anonymous simple. In this case, yes, this is a case that we are using anonymous simple type. So because we still have XML type is nothing, so we want to actually have anonymous type. And then this is basically a simple type, so we actually have a simple type right here as anonymous type. Okay, so that's exercise 3. So yeah, this should be E. So we already have done exercise 3. Basically we created the purchase order type, complex type, right? Okay, with the type. Yeah, so this is basically what we have already covered. Okay, so we are going to move on to exercise 4. Yeah, this is number 6. So define a factory class. So this is actually a factory class. So here we can say XML type, and the name of the type is US address type, and then factory class and factory method. So in this case, what we want to do is, we want to actually create the US address object from a factory class. So this is the US address factory class, and then we are just generating the US address from a factory with this object. Okay, so in this case, we are basically creating the US address type along with an object instance. Okay, providing a factory class and method. Let's actually do exercise 4. That's actually using factory class. Okay, so when you actually run the application, it's going to create the XML. Yeah, so this is basically what gets displayed. This is the value that was generated as an object. Okay, and then we display the schema. Okay, so schema is again nothing really different from what we have seen before. So we have a global element of purchase order. Type is a purchase order type, and then we have a purchase order type with complex type and US address type. So nothing really fancy about this. Okay, the only thing that is actually object gets actually created automatically. So that's basically like a dummy name, dummy street, and XYZ. I mean, that's basically what gets displayed. Where that is actually being displayed. Oh, we're still actually reading test data. Okay. Yeah. Okay. I actually give the wrong information. So this factory class is actually basically giving you, the US address object. It's basically using object as a way of actually kind of figuring out what are the properties. Okay. That needs to be used to create the XML schema data types. Okay. All right. So that is exercise 4. Let's see. Let's move on. I'm going to actually finish up the presentation because we have only 16 minutes. So that's exercise 4. The next one is Java to schema annotation, which is the XML schema type. So it maps a Java type to a simple schema built-in type. Okay, so this is probably easier to understand. So in this case, we are mapping this guy. So date into well, you're basically converting Gregorian calendar type into the XML date type. Okay, so when XML gets generated, you can see it is actually using date XML date type. Okay, pretty straightforward. Yeah, so the thing is, the reason that you might want to use this one is that because the mapping of Gregorian calendar could be either X date or X time. Okay, so if you specify here as time, then it will generate X as time. If you specify here as date, it will actually generate X as date. So between the two choices, you can actually specify it using XML schema type with the name, date or time, either one. Okay, so that's exercise 5. And this is for XML attribute. Again, we have seen examples of this, right? Okay. So the maps Java beans property to XML attribute. Okay. So yeah, there are actually a few rules here. So if the type of the property is non-collection type, then the type of the property of the field must map to the simple schema type. So this one is legal, okay, but this is not legal because you cannot actually map this complex type to a simple attribute. So attribute cannot be complex type, right? Okay, so that's the reason there is so this int is okay, and this is list of integer is okay, but you can actually have a list of bar, which is a complex type. Okay. All right, so that's XML attributes. So in this case, we want to actually have this price to be an attribute. Okay. So this is a getter method and setter method, and basically, yeah, by the way, we can use this XML attribute on a property, or you can actually use it on, getter method or setter method. Okay. So in this case, it's going to use this price as an attribute. Okay, so that's XML attribute. In this case, XML attribute of list of integers. So in this case, it's going to be the list of things. So, the attribute could be a list of things, right? So it certainly actually supports this syntax with a list of integer, and then it's going to be the list of int. Okay. All right, so that's exercise 7. I'm going to actually skip this one, XML Java type adapter. So this is actually, for creating, if you want a really customized behavior of, then you can actually create the Java type adapter. Okay, this is actually rarely used. Okay, so basically you have a complete control in a sense. All right, so I'm gonna actually finish up right now, and I'm gonna give you guys about 10 minutes to finish up the all the exercises. Okay, yeah, good.